talk a little bit more about the ambiguous case for the law of sines. So I have an example here, and let's emphasize how to draw the triangle and to determine the number of triangles that are possible. Okay, so when I draw this, notice you're given side, side, angle, right? Lowercase letters are the sides, uppercase is the angle. We always want to draw this in what we consider to be standard position. And that's that I'm going to start by just drawing a horizontal line, and I'm going to make an angle on the left. That is always going to be the given angle. And notice, it's not, you don't want to think like, okay, that's always going to be angle C. It's always going to be the given angle, whatever the exercise calls it. It could be A, it could be B, it could be C. In this case, it's C. So this is the given angle, and that's 61 degrees. And that's what I want to start with respect to my picture. Now, we know that opposite angle C is side C. Opposite angle A is side A. Opposite angle B is side B. So that's how I have to draw this. So side C has to be the side opposite angle C. So side C is going to be over here. And again, that's what's unknown right now, but I'm just going to draw it kind of small and label it for the time being. The other given side you always want to draw here. So this is going to be, and again, in this case, it's called side A. And so that's what I'm going to call it, and that's what I'm going to label it. This is always how you want to draw your picture. Okay, so now I think the best thing to do is to consider the two sides. Okay, so this side C, opposite the given angle, is smaller, right? C is smaller than side A, and these are the given sides. They could be any letters. This is this case. In that case, whenever this side is smaller, then that's when I have this ambiguous case, and I will either have two triangles or no triangle. If this side happened to be bigger, then I would only have one possibility, and I would just use the regular law of sines. I would have enough information. But since this side is smaller, I have to do a little bit more work. So the next thing I would suggest doing is find the height. Okay, so find H. H is going to be, if I drop this down, right, to a right angle. So by finding H, I can just use a regular old sine ratio, right? Because I want to know what the opposite side is, and I have the hypotenuse. So I can say, okay, sine C is equal to, or let's just call that 61. We know what that is. So sine of 61 degrees is equal to H over 184, the hypotenuse there. So H is equal to, and again, we've done this before, so I'm going to just jump to what H is equal to instead of pulling the calculator up. So when I do the math and multiply sine of 61 by 184, I get H to be 160. Or not 160, but 160. Sorry. I couldn't tell on my paper if that was 16 degrees or 160, but 160 would make sense given the length of the other sides. Okay, so now I want to compare this to my other sides. So 160 is smaller than side A, which is 184, right? This is H, but bigger than the side C, which is 133. Okay, so what does this tell me? Since H, my height, is bigger than the side that I'm looking for, that side C, so since H is bigger than side C, this tells me, because this is the longer side, that side C will never make it to the other side because it's smaller. So in this case, there is no triangle. Okay, so let's take a look at another example. Okay, let's grab this one. Let me just move it over so we can see it a little bit better. Okay, so same directions, side, side, angle, right? So we're gonna do the same thing. We're gonna draw the picture the same way, right? I'm gonna start with a horizontal line, pretend that's straight, and the given angle goes here on the left side. So I'm gonna call that whatever they're calling it. In this case, it's B, and I'm gonna label it, that's 19 degrees. So that means the side opposite, which is going to be that side B. I'm just going to draw it little for now. And then that other given side, in this case we're calling it A, is 6. Okay, so again, note that B, the side opposite the given angle, is smaller than this side A. So that means, again, I have either two triangles or none. So I'm going to find H to see what the possibility is. All right, so H, again, that's just going to be the height that I'm going to drop at a right angle. And then I'm going to set up the trig ratio, which is sine of 19 would be equal to H over 6. So H is going to be 6 times sine 19, which is 1.95. Okay, so now let's compare it to the other sides. So notice 1.95 is the smallest. The height is the smallest here. So 1.95 is smaller than B, which is 4, which is also smaller as we identified in the beginning of the given side, side A. So since H is the smallest here, then I will have two possible triangles. So let's go ahead and we're going to use now law of sines to find all of those possibilities. So really what that means is that, let's see if I can draw a decent picture. My side B can either be extended here or here. Okay, so if that's the case, now let's just kind of talk about all the different things we need to find here, right? So here's side B. So side B can either be here, 4, or here, and that's, again, still 4. So then side, let me make that like that. So opposite side A is angle A. So angle A can either be this angle or this angle, right? So that's also could be A. And then I would have two possibilities for the angle C, right? So angle C up here could either be this guy or this guy. And then that also gives us two options for side C, right? Side C could either be right here or that full length. So those are all of the different things that we now need to take a few minutes to find, okay? So let's start by finding angle A. So we're going to use law of sines to find our two possible angle A measures. Okay, so let's talk about what we know. So we can say we have angle B and side B, right? So we're definitely going to use that. So sine of 19 over 4 is equal to, and then we'll set up for angle A, sine of angle A over, we know A is 6. So then we'll do the math. Again, really to find sine A, we're going to multiply both sides by 6. So sine A is equal to 6 sine of 19 over 4. And so sine A, I'm just going to kind of shortcut this just a little bit to save some time, is equal to 0.48835. And then to find actual angle A, we would take the sine inverse of that. And so angle A is equal to 29, I'm going to round 0.2. Okay, so that would be the acute angle, which would be right here. To find this angle A, the obtuse angle, we would subtract from 180. So that would give me 150.8 degrees. So that would be, again, this one right here. And so why don't we start, we'll just kind of keep track of what we're finding. So we're finding two triangles, right? So we'll call this number 1, and then we'll do number 2. I'm just going to identify the angles that we know so far. So we'll call triangle 1 the big triangle, where A is 29.2, B is always going to be 19. We'll put that in both places. And then my other A is 150.8. Okay, so now we have two possibilities for that top angle, angle C as well. And really, since we have two angles and we know that all angles sum to 180, again, I don't need to set up another ratio. I can just add the two and subtract from 180, right? So to find angle C now, I can just say for that first one, right, it's going to be 180 minus, and then just adding those two together, 29.2 plus 19, right? So I'm just going to subtract that sum from 180, which will give me 131.8. So that would be this angle C. And then to do the same thing for the other one, add 150.8 and 19, subtract that from 180, and we get a C value of 10.2 degrees. That's a 0. Okay. All right, so now we have all of our angles. We just now want to find, let's see, what else do we need? We need side C, right? So let's do that. So we have A, B, and C for both triangles. A and B were given, right? So this is 6. B is, excuse me, 4. And C is what we're looking for. Okay, so we can do that. So we'll set up one last law of sines. So to find side C, let's go back over here. All right, so let's set up, again, use a proportion or a sine ratio with the given information, because you're going to be using exact numbers then. And by that I mean that we know, this angle was given and side B was given, so I'm going to use that for sure. So we can say sine 19 over 4, and then to find side C, let's start with the first triangle. So we would use the 131.8 over side C. So then again, I always think of just cross multiplying. So we would have C times sine 19 is equal to 4 times sine of 131.8. So C is equal to this divided by, sine 19. And so C in that case would be 9.2. So we found that. I'll fill that in up here. And then doing the same thing with the other angle, or yeah, angle C. So we would say sine 19 over 4 is equal to sine 10.2 over C. And again, cross multiply, and we end up with a C value of 2.2. And so we solved the two triangles. And again, it really comes down to finding H and doing that comparison. So remember, H was smaller than that side B in this case. And so we knew that we were going to have two triangles opposed to the first example that we looked at when H was in between the two, where again, C is smaller than the given, but H was bigger. So I hope that helps. Again, remember when that side opposite the given angle is larger than the given side, you're only going to have one possibility, and it's just a straightforward law of sines.